Papa Bale. Welcome to the channel. Please like, subscribe, think about becoming a member, hit the notification bell. Remain up to date with all my content. Currently have about 2,700 videos, all based on pretty much the same things, but everyone is different. So like all the experiments either people didn't do because of math or other things kind of along the same lines, though, just a bunch of stuff that people have and haven't tried, having to do with pulse motors and electric generation and spending the least amount as possible. Oh yeah. So my kids are being a little obnoxious right now. See, I'm trying new things with the permanent magnets, and they're, doing different things. All right, just a minute. Get outside. Right now. All right. Yeah, they spilled a bunch of spaghetti. Now they're cleaning it up. So, yeah, like I was saying, I'm experimenting with, and this one's kind of interesting. It's got the strong magnet in the back that's in repulsion phase to these magnets right here. And then it's got this little one in the front that's in attraction phase. And it's got the iron holding it in place, holding both of them in place. So there's a little bit of attraction, a little bit of repulsion. First thing I did was make sure that this one in the back could reach the ones on the wheel, and it's good. So it's shining right through everything else. Awesome. But this is what I really wanted to talk about, is over here. So I was messing around with the pot, had a nice little space there for me to put it in and hook it up. So I did that. And still 460 is about the best one that I can do. So I have this SSG combo, which is generator mode, hooked up to one battery. And I got standard SSG hooked up to the other battery. So let me start this up. Oh, it's already going pretty good. So we got both outputs charging each one of these batteries right here. Let me change this. God, I wish I had a cameraman. All right, see these batteries right here are they're both being charged right now. Wow, this one's almost a 13. No, it's already at 13. So this is the combo, and it's charging way more rapidly than the standard SSG. Wow, it's impressive, actually. When you think about it, it's a 20 amp hour battery. Let me think here. My favorite dinosaur is me. It's got to be me. But what dinosaur would I be? Uh, Brachiosaurus. All I do is eat leaves off of trees all day. Awesome. All right, so this one over here, I just shut the other one down and we'll see how far it drops back, how much it actually charged up. This one's at 12.97. I'm going to cut it off in a second because I started it later. But I think this right here is an ingenious idea because it has the repulsion and the attraction happening in the same space. And there's no right or left side to it. It's all happening in the same space. So I think that's pretty cool. What it does, I don't know yet. So this one's dropped down a lot faster, and this one is being run by this coil right here. And I think it's dropping faster because it's got a trifilar strand that is not hooked up currently. So what I'm going to do is hook it up. Okay, so negative. I don't know if that's on there. All right, so everything's hooked up. Let's turn it on. See how fast it charges now with both things hooked up to it. Let's see. Oh wow, that is going pretty fast. Oh yeah, that's going really fast, actually. Mike! Whoa, dude. I mean, it's not thief quick, but it's like really fast. It already went up 4/100ths. Well, 12.93 to 12.96, 12.97. Wow. And then when I turn this one on, it's got that's just standard SSG, with the Trifilar. This one is combo mode, so it's got a little bit more output. All right, let's see what we're getting on the meter. Wow, it already went up. Oh wow, dude, no, combo mode is the winner, hands down. That's amazing. It's already at 13.02. Dang. It's ripping. Wow. And so, but with this one SSG and a Trifilar, I can charge both batteries and have this just totally for something else. I tried charging a battery with that cap bank over there. Let me see if you can see it. Yeah, you can kind of see it. It's kind of this right here can charge a battery no problems. And it's cool because it has a backlash up to the light bulbs, because the light bulbs are after all the caps and bridge rectifiers and all that. It's on the end. So through the resistors, the batteries will light up the lights. That's not enough to make anything change really, but the lights do turn on from the batteries that they're charging. But when you turn it on, it starts going up, man. Now I have them both hooked up. When I say both, that means I have the output and the Trifilar strand, which is hooked to this thing. So all that's coming out of this cat bank is coming off of this third strand that I have in the coil. So it's got transformer and induction electricity going through it. But as soon as you turn this off, it loses about 6 volts instantaneously. So you know there's transformer action going on in there. It's cool. And it's staying up there, 12.98. Yeah, I think this one's charging pretty good. This one's down at 12.95. Huh. Oh. See, that's the thing that I know that none of the main connections are gonna be off, but whew. I love that rotor too, man. It is smooth as a baby's butt. So I was just messing around trying to get the magnets in the gyroscopic holders to, gyro. That's what started all this. Because if it flips, it'll gyro. Because of these ones. But I think it's cool because you got this attraction happening immediately, and then you've got this broader from the back repulsion going on. It's pretty much the same as any other one, though. Yeah. All right. a long time since I like played a game on the PS5, man. It's and I don't use it for gaming that much. So this one's down at 12.96 now. But it was at 12.88 when I started doing this. All right, so well, I think I've explained it pretty well what's going on here, but we have two inputs to this battery for charging, which means the output of the SSG and the Trifilar strand through this cap bank are charging this battery. And then the other battery, which is here, is being charged by a combo SSG generator combo. Well, it's just the SSG generator part of the combo. And it's not plugged in right now, but we're still 0.07 up from our last mark, which was 12.88. And it's just simmering right now. It's 12.95. I think it'll go down like one more, and then that'll be a total charge, like keep a charge. I just got to remember to unclip the multimeters. And it's so quiet. I used to I made coils that would chirp a lot. But now that the load or the output is connected to a battery, it seems that all that chirping has gone away. All right, that's pretty much all of it. I'm wondering, I mean, I love that rotor, but I'm thinking maybe some stronger magnets might have better yield. But I don't know. I don't think it has anything to do with the strength of the magnet beyond the induction of the trigger coil. But I think I could totally be wrong about that, because induction electricity stacks up with speed. But this has got 12 magnets on it, and it goes pretty fast, so I don't know. I'm left scratching my head, you know. The math would probably say that this 4-magnet rotor is going to generate more than this one. These magnets are a lot weaker, but I think at every pass you get a reaction from the motor, which is awesome. We're going to check it out anyway. All right, I think those stacks, yeah, that's good. It's resting on the bearings, but that's fine. So I'm going to turn this on. This one's got a little bit of fabric softener sheet on the bottom of it. Oh yeah. Wow. So it moves, I don't even know what's going on here, but it seems like it's going a lot faster with just the 4 magnets. I wonder if I just did 2, what would happen? I think 4 is better than 2 though. Not just because there's an equilibrium of speed and generation. I think 2 will go faster, but you only get 2 hits per revolution, so I don't think it goes that much faster. Wow, so we're at 13 across the board, almost 13.1 on the other battery. Yep, there it is, 13.1. So I think not only are we doing it faster like this, but we're also doing it with stronger magnetic force. But I got the 2 magnets right here. We're going to set that up. We're going to see how it goes. This one is maglev, and it's used for 2 purposes. 1, to take a little bit of weight off, and 2, to hold the magnets in place. So now that's lined up right with the center, which is okay. Just got to rearrange the coil a little bit. And then with these 2 magnets, we can arrange the coils a special way. And we're going to do that in a little bit. All right, so at 12 volts, if it's on, it's not drawing 100 yet. All right, so we're at 13.03 and 12.97. This coil is 13.05. No, it's a 13.06 now. Wow. And this coil is 12.98. Look at it starting to move. About 350 milliamps for this coil. About 400 for this one. I wish I had batteries that were a little bit lower and were, you know, still functional. I think it's sweet. But I don't know if we can run battery load with them being fully charged pretty much. We can run a swap though, that'll be sweet. And that brings me to my next point. Mike Dawes has been kind of hinting towards a swap that is timed due to position instead of anything else. It's basically just you got your 180 magnets, and then you're going to put your coils at 90 degrees. You'll have two coils, one here and one here. So when I should do it, just do it. Dun, dun. Oh man, I gotta make sure nothing's touching once I get this over there. Make sure it's all still hooked up too. All right, so that's how it would be laid out. You got your 90-degree coils and you got your 180 degrees. So every time one's on, the other one is off. That makes sense? Allowing for things to happen and giving it enough time for things to happen. But I think I'm going to use my relays. Or one relay, maybe. No. Let me think here. We're going to have them swapping, but the swapping is happening pretty much automatically. I'm wondering if I can't just hook it up solid to the batteries from the SSG outputs. Well, I can't see, that's the thing. I can't do it with these ones because that one can't go to generator mode. And the one that I have may be able to do so. The one that I have had previously. Yeah, I can still switch it. It was stuck, but now that it's been chilling for a minute, it switched over. So I can run this one over here and then we can run a swap. Oh, that's going to be sweet. Because the circuit board here is built, has the Schottky diodes built in. So anything you put through the output is going in one direction, and that's away from the circuit. At least that's what I think is happening. And then there's the negative spike or the reverse flyback diode that is, counterintuitively placed. I believe that is also, it's not going to get in the way because it's hooked up to the negative. So, if you understand what I'm trying to say. But you know, the SSG will charge and does charge, do a pretty good job of charging um, by itself, you know, on its own without generator mode. I always thought it did. And generator mode is obviously better, but I think it also, you know, paints you into a corner. Once you spike your batteries, they don't really like anything else. Not like you can't, I guess, with a little bit of diligence, change it all back if you wanted to. But I heard that once they get the spike, they like the spike, and that's all they like after that. See, because this is why when this is on, when the magnet is passing this coil, this one's off. And when the magnets are passing this coil, this one's off. So you get a natural break and stuff, and they alternate being on and off, which, you know, in my mind says that you can charge when the one is off, and when the other one's on, you're charging the other one when there's two of them. So that's all right. So this is good. The other one, the combo mode, still charging a lot faster, but I can hook a combo mode up here, and that'll be awesome. But these are two new circuits that I was trying out. I wanted to test the SSG against the SSG combo, and it's not even a competition really. But the SSG does generate. And look at that. That thing just wanted to keep on moving. All right. I hope everything's working with that. Generator mode, because it was a stiff the last time I checked, but this time it just kind of moved. So, but I don't know its condition. See these, well, let me think. See, these lights are on, they're really bright too, so that's the backlash from the battery that I was talking about. Almost ready. Just gotta get this trigger coil in there. All right. See, these screw connectors are pretty easy to use. Oh, I hope I didn't lose it. Yep, lost it. Oh, I knew I forgot something, but it's almost ready. We'll just put you right over here. Yo guys, check out kenergy.store. He's got a lot of cool stuff. This SSG combo circuit is just one of them. I mean, if you're into DC brushless motors and stuff, he's got some pretty cool things. He's got a lot of different stuff too. Really cool. We're good. Oh yeah. So, Mike, I'm gonna try and hook up your relay, positional relay. Thanks, Yanni. Really appreciate you, man. Thanks for coming in. Got tons of cool stuff. This is like one of my favorite ideas, though. How the magnets are stacked on this stator. I don't know, like, it doesn't work the way I want it to, though, but it's a good idea. Alright, let me check where the batteries are at. I gotta keep doing it pretty. So 12.97. $12.98. I just want the generator capabilities to be kind of equal on both sides. And it looks like on the other side, and it's probably due to the coil, the differences in the coil. This one's thinner, so it's generating less electricity. And I don't know why that is right now, but it is, because I think it's the transformer part of the whole thing that's really bolstered on the other coil. It's 18 to 20 instead of 20 to 22. Up 12.99. All right, so yeah, we're gonna hook that up. Um, ah, yes. I would like to hook this up. Huh. So it's going to swap between S and R. And yes, we do have a 1R and a 1S and a 2R and a 2S. Then we have this C thing. I don't know what that's all about. Ugh. Maybe that's a third one. No. This is a dual. This is do. Maybe for now I'll just use these ones in the power supply until I figure out exactly what all the connections mean and stuff. But I kind of see how it works just by looking at the bottom here. You're going to hook up one side of each thing to your corresponding strip of conductiveness. And then the thing in the middle swaps between S and R. But I don't know what C is for. It's like maybe C is part of it. Maybe it is 3. It looks like it's part there's 3 conductive strips. Yeah, it looks like C is the 3rd one. Yeah, that's got to be what it is. But that's confusing because I didn't buy one that had 3 in it. But I guess this is just a bonus. It's got to be a bonus. That's awesome. All right, I'm just going to charge this one battery up a little bit. It's got to get, do I have any connectors available to even attempt to start to do that yet? I don't think I do. I think and if I'm going to use the wires, I still have to make those. Like strip the wires, clip them to their proper length. But it is something that I would gladly do, and I had done, but you know, I'm using them elsewhere now. It's a pretty good clip. I'm gonna use my tack meter. So it's going about 1,025. Oh, me too, man. Well, I've been doing it for a few years, but yeah, I consider myself to be very new. Just based on, you know, lots of things. Based on what I know, based on how much success I've had, and based on, you know, yeah, basically what I know now based on what I knew then is a little bit more. So, yeah, man, Peter Hall Effect 10, or Peter Hall Effects, Peter Hall Effect X, it taught me most of what I know. And then there was a character 007, and he taught me a lot too. Mike does. Taught me a lot. Old Man Builds, learned a lot from him. Right here, K Energy Store. These circuits here teach me a lot every time I use them. Like how you can have all these things in series and then connected to the transistor. It's like, I didn't know any of that stuff. That's awesome. Yeah. I think the Trifilers are really, okay, we're up to 13 on the battery now. That's awesome. Trifilers give you a little bit of extra energy, especially if you use them right or make the right transformer style. It shouldn't be more than 2 gauges below your drive coil. So it's like you got 20, you should have either a 22, well, it should be 22. If your drive is 20 or 20. You can make it a 20-20 and then your trigger, or you can make it a 20-22, or you can make it an 18 and a 20, or an 18 and an 18. You know, in order for the transformer thing to have the pow it should have, what I mean by that is usable electricity that can like run another motor. You know, in order to get that, it's got to be pretty much a 1-to-1, and you get literally on most occasions half of what you put in automatically, and then anything else you got going on to generate electricity will stack on top of that. So like immediately when I turn this off, that Trifilar strand is generating like 12.5 volts. When I turn it off, instantaneously it goes down to 6.5. But it's still up to 6.5. You get what I'm saying? You've now generated 6.5 in electricity that's based on speed and magnetism off a 22 gauge strand, which is, in my opinion, good electricity. You know, generating anything off of a gauge that's thicker than 26 is, in my opinion, it's awesome. So 26, 24, and up 22, 20. Now when you're doing straight generation, you want to go thinner. You want to go, and you can do that too. You can go, I have a 32 gauge coil. All right, this one is very interesting because it's a bunch of, it's the end of a bunch of coil spools. So it's the end of spools. So I got an 18 gauge wire that goes about 150 turns on this spool. And then I take out the end and keep wrapping the other 4 strands that were in there. So the 24 gauge is 350 turns altogether, and I got it in series with the 18 gauge. So that's my drive right there. And then I got 350 turns of a red 32 gauge. And then I got 8,000 turns of this gold 32 gauge, and then they all started wrapping at the same time. So they all ended at different times, really, except for the 24 and the 32 gauge strand are the same length, except for the fact that I have it in series with the 18 gauge strand. I know that's complicated, but I get the transformer effect because I wrapped all these inside the 8,000 turns of 32. So I like cocooned it inside itself with a very high generating electricity. Yeah, I was like, wow, and it works. I mean, it draws about an amp. Like, it's very expensive to run it, but that's why I'm not doing it right now. Or I would, because the generation that it puts through this cap bank right here is amazing. And it's like, it's just, it's easy. Yeah, but I'm literally gonna make a pure 32 gauge coil that is 3 1-pound spools in parallel. I mean, short of twisting it all up, I'm gonna make it just a parallel coil. And then I'm gonna have basically 3 coils right on top of one another. But it's gonna be something like this. At least I think. I haven't done it yet, so I don't know. I might change the bobbin shape to like a square, more squarish center. But I don't know. I don't know if I want that because none of my cores are square. Uh, this is soft iron. And then the one on this side is iron ferrite. 4 separate pieces, 2 inches long, about, I don't know, 3/8 of an inch in diameter. And then I wrapped each one in tape, and then I taped them together so they're pretty isolated. They don't touch each other. And then once I get my relays hooked up, there's something special that happens with this setup. I don't even know if I need relays, actually. I mean, I think I do. But it's like when one is spending, when one of these coils is spending, the other one is not spending. So it should be charging. And then when the other one is spending, the other one should be charging. But I think that if I don't use a relay, that's going to be happening at the same time. But it won't. It won't. I got to think about it like when one of these is off, the other one is on. When one is off, the other one's on. When the other is on, this one's off. So what can I do with it when it's off? I could charge it when it's off. Right? That would be awesome to charge it when it's off. And then when it's on, you know, I'm spending and then charge the other battery. And I don't think any of it would be happening simultaneously. So I think it will all happen based on the positioning. And because I have the output of the SSG, which makes it so much easier to sort out what's going to happen. Because it's like a direct connection. So, I mean, the last thing we can do here is give it a shot. All right, sweet. Oh, it has a name. All right, we're going to name it then the Bedini Bounce. And that gets going with some momentum, man. That wheel. I mean, it's pretty flywheel. It's 100% 3D print infill with academian, like record style print on this one. That's pretty tight. You know, it's very solid piece of plastic. we're just going to get all of our clips together and we're going to get them on the right way and then we'll start it up. Just gotta get all right. Let's spin that. I'm gonna get some lumber in the next couple weeks, and I'm gonna redo this whole thing. I know I've been saying that, but it's like a tedious job for me, and I don't want to do it, but I'm gonna do it, and I have the money to do a little bit of it, so I'm gonna do it. I already have most of what I need. I just need something underneath the cork board or the pegboard to keep it flat, because it's all bent out of shape. All right, we are hooking up. All right, so that's that, and then these two are going to go on the other battery. Huh, it's humming. Should it be humming like that? Here, let me see if this is working. It's working, but oh. I don't really hear it anymore. All right. Right. Ooh. I just need hook the power up to the other battery, which is now I might even want to hook this Trifilar up in series. Oh, here we go. Yeah, these two will work perfectly. So it spends less. Because the other one's hooked up in series right now, and it's spending quite a bit, but it's a lot thicker gauge. All right, so all the connections are hooked up. I just need to get, wait, no, we're good. Power, it's all good. Let's see what happens. Something not right with this coil. I'm going to start that over again. It might be a transistor. Because remember I said I heard that sound? Yeah, that might be what it was. Make sure everything is like not touching. I keep on smelling that. It's not good with that smell. It's not good. You know what? That's what I got to do. I got to unhook that. And make that into the Trifilar drive real quick. And then I need to switch out that transistor. All right. So I'm just making that drive strand a little bit longer and a little bit thinner. Just like I did on the other side. Okay. Okay. Boom, boom, boom. Now, I don't want to get my wires screwed up. Transistor. And then if anybody wants to discuss with me how to use a PNP properly, I got tons of PNPs. All right, we're going to start this over again because that's how I feel about it. All right. All right. Power on. Did that one backwards. Come on. Thank you. All right. One down. Wait a minute. Put output. Almost ready. Hopefully, with the swap of the transistors, everything will be all right. Huh. All right, let's see what happens. Oh, these aren't hooked up. I think we're good. I just don't have my multimeters hooked up. I know what I can do though. Oh man. All right, this multimeter just died on me. All right, let's see. 12.81. This one's at 12.96. That seems 91. Going down. All right. So I'm thinking that honestly, without them being the same coil, this system won't work. But it's working as for the swap. But the amount of electricity being generated has to be the same. Therefore, it has to be the same coil. And I'll get on top of that. I really want to see this work. This is basically swapping without any kind of relay. But I want to see both sides gen at the same rate. Yeah, this is sweet. But I don't think... And this transistor might be bad. This one right here, that's really not cool, but I mean, I see the coil bouncing around. It's probably just because of how slow it's going. Yeah, that's smooth. I'm gonna get one more reading on, let's see here, on each battery real quick. Yeah, that's going down 79. One's going down to 795, 94. Oh. I think they're going down like slower than they would be if we were just running them separately. Yeah, 12.96. There we go. 12.94. I feel like it should be going faster than this, so I'm going to swap out yet another transistor. But I might be just greedy. Later, man. Thank you for coming in. All right, so it's staying at 12.94 pretty constantly. I was just trying to make room for another multimeter to go on this other battery. All right, just regroup here. Wow. Okay. Man, and this isn't going to stay on here. There we go. Now, either that's going to rebound or I got to do 2 more transistors. All right. Where's that black clip? Here it is. So do this. Wow. That battery is very much dying. It's at 12.45 now. Huh. All right, let's see. All right, so this is a relay swap between the batteries without using a relay. I'm not sure exactly what I'm supposed to be looking out for, but as far as I know, this is working. Maybe a transistor is a little weak, but I say yeah. Or it's just spending at an exponential rate. And I think it is right now because my coils are different. I need to snag the cord here. All right, so this battery is at 12.46. This battery is at 12.9. I think that's a little bit too far away to do an honest. Ah, it's going up though. Huh. I'm gonna get some glue. wonder where that's coming from, man. It's bugging me. Oh, that's where. My coils are getting hot. I can smell that a mile away. And it's because it's not going fast enough, which makes me think my positioning is a little off. Looks right, but you know, something about it isn't right. This one's cold. Huh. But this one is hot, man. It's hot. I felt it getting a little warm in here. Whoops. Let's see. Is there anything we can do to cool it down? Huh. Huh. I don't understand why it was getting hot. Other than it could be the transistor. But you know I just swapped that one, right? But now the batteries are unclipped. Maybe. I think they were unclipped the last time too, but I'm not sure. It's a little warm. I'm going to double test all these, make sure they're broken in the next week or so. Um, I'm trying to do the Bedini bounce here. But I think I should, I don't know, man. I think I need coils that are the same before I try it again. Now, what I could do is I could run the 20 gauge on this side and the 20 gauge on that side. But that 20 gauge is like twice the length of this one. At least they'll both be 20 gauge. Yeah, I don't know. There's a lot of experimentation that needs to be done. This 18 might just be, the 1 millimeter wire might just be too thick. We can use that as the Trifilar. All right. So we got Trifilar off to the side. We'll do the same thing over here. Okay. I'll look and see who that was in just a minute. Now these coils are very similar in their makeup. All right, let's see here. Yeah, it didn't feel right. There's lots of sparks coming off the battery, so I don't know. All right, let's get this in here then. All right, we're getting some generation here on the short battery. It's generating pretty well. I think it's moving faster too. I smell something burning, like a resistor or something like that. That's all right. Tell you what we can do though. Oh. We're gonna gen up these batteries. Both of them. So I don't know exactly what was stinking, but it smells like a resistor. And that's on that side. So I mean, there's maybe a little bit more refined stuff needs to happen. You know, maybe it needs to be 91.5 degrees or something like that, you know. Maybe the resistance needs to be a certain way. Hmm. yeah, that's something I didn't use, which I should use in my next relay. And that is capacitors on the battery input are negative and positive. Across that would probably help. And in the meantime, I will make another, 2 coils that are the same. Sure, thank you. I don't understand the Russian language in its written form. So, thank you. I hope we're straight, because I don't understand. There we go. All right, let's check our batteries. And maybe I'll get some better connections before I try that relay again. For the battery at least. There's not enough room for all that. So 12.78 and 13.01. Wow. There it goes. I was going to be like, all right, I'm just going to charge both batteries with the one circuit. I can do that. With the Trifilar strand, there's enough coming off of that strand for me to charge 2 batteries at the same time. Alright, so there's a ferrite core in this electromagnet, and it's attracting this magnet, which is repelling the wheel magnets. Okay, so there's a repulsion coming from the big cylinder in the back, and then this little rectangle in the front is attracting, but it's also attracted to the ferrite core in the middle, which the magnets are attracted to, yada yada yada. But what it is that both the attraction and the repulsion are happening in the same spot. And is it an answer to make it move forever? No, you won't move forever, and permanent magnets will never have a motor, because that means they'll move forever, and it just won't happen. I've seen quite a few of these things. I think there's two out there that I think are legit, and both of them are from Daniel's Inventions. That guy is brilliant, and the stuff that he makes, I think all of it works, at least some kind of way. And he makes permanent magnet motors, and they work, as far as I know. I think it's really cool, though. I'm just experimenting with my own ideas and then showing them to you. And I think having everything, attraction and repulsion, going on in this little spot right here is awesome. Like, what if I did that 8 times on this rotor? What would happen? I think we get a little bit of torque. A little bit. I was trying to get those gyros to spin with the magnetic force. See, you spin them this way and they'll spin this way. Really neat. That's a 3D printing marvel. 12.81. 12.81. 13.07. And I guess people don't like me saying that it's not going to move forever. And if you ever got a permanent magnet motor to spin, it would spin technically forever. As long as everything remained in the position that it needed to be in, there should be nothing that would stop it. And I think that's why it doesn't happen, because, or there's no like true, evidence of it happening. It isn't because it's been squashed. That's not why it is. Okay? No, I'm not saying stuff hasn't been squashed, but I just think that people have been working with magnets for the last 20 years and done fantastic, phenomenal things with magnets. None of them have been a motor that spins forever. And I mean, if it's going to start spinning and it's a permanent magnet motor, what's going to stop it? And I mean, a lot of these builds suggest that it'll start spinning faster. And I think there are a few builds that do that. And like I said, 2 or 3 of them come from one guy. He always uses legit material of stuff that he's replication. These are replicated things that have been done before. And I'm starting to think that's the better way to do it. To replicate. But I don't know, man. I will always do my own thing, but the replication proves how it works better than just doing your own thing. But you can like do your own thing on a replication as long as you state the fact. People would argue that, you know, this is a Bedini, and this circuit right here and the one over there are Bedini circuits, straight up. Bought them from K Energy Store, kenergy.store. Go check those out. He's got a lot of cool stuff. These are Bedini circuits. This is not a Bedini coil, and neither is this. These are Trifilar coils. This is way too small to be a Bedini coil. And this is just not even close. What's cool about these coils is that they're wound in repulsion phase. So you go a layer over, and then you go two turns back, 100 turns this way, 2 turns back, 100 turns this way, 2 turns back, and you build your coil like that. I know for a fact that this coil is built that way. You can kind of even see it in there, 2 layers. On that back layer, there's only 2 turns. All right, well, let's see here. I think I figured out why that's not. Oh no, I didn't. Holy cow. It's just charging really slow. I think that's because half of the coil isn't involved. See, this coil is 730 turns. This coil is like 350. So it's like halfway, or you know, it's not even halfway. It's like 2/5 of it is the circuit. 3/5 of it is the coil. The coil is the heart of your motor, not the circuit. Because the circuit will only like be as good as your coil. And for the longest time, all I wanted to do was build coils that, you know, were fast and did speed real well. Not ones that were really built to generate in any kind of way. That's why this coil right here doesn't generate very well. It just doesn't. Because it's small. It's not only do you need it to be about that thick, but you need it to be about this long. You know, like twice the size that it is. But I'm not going to take it apart. It runs really good for speed. All right. Well, thank you all for chilling. I think we've ground this sword down to a stump, down to its hilt. Let me see if that's hooked up or lined up right. Yeah, it's good. 90 degrees. Perpendicular. And as far as I could tell, there was no interference on the batteries. The batteries were functioning correctly, and they were not hooked up to a relay, and they were swapping. So that That is proof of theory. And that is the Bedini bounce. I just need to get two coils that are equal size and length. Have the same core material. You know, a few things need to be changed, but I think all in all, this will last quite a while if everything is generating properly. Oh, that is so neat. And then as soon as I get the coils right, I'm sure that the spending and the, you know, I'm sure that it'll balance out. It won't stop going down, but it'll go down a lot slower than it went today. I'm satisfied. You know, I'm pretty. You can see these gyros trying to flip just from this spinning. Look at how far. Look at the distance. That's awesome. That is literally like 1.5 feet distance between the rotor and this one over here that it's affecting. Maybe even 2 feet. No, 1.5 feet. Huh. That's awesome, man. Those magnets are more powerful than I thought. All right, and all I suggest is that you play with like build a rotor, some magnets in it, then get your permanent magnet stator. And then, you know, do your experiments. How much force does it need to go all the way around? How far does it go once you've gotten it to go all the way around? How much farther does it go? You know, find a way to measure exactly how much power you're putting into it. Wow, that is awesome. To me, when it stops and then it goes again, that's power. Not this just continuous, yay, anybody can do that. Anybody can make it look like it's going forever, like it's affecting. You know, I'll just remove this completely and I'll spin it faster than anybody's permanent magnets. You know, you just move it out of the way, all the way out of the way. Now that thing will go farther than it ever would with this in there at all. And that's the truth. You might think that this coil has something to do with it, but it's not plugged in. But you know, I like experimenting with that, coming to a basic halt and then continuing. Like that. Like how many times will it be able to do that? And I know it's not that interesting, you know, this is more interesting. Spin it like that. And I guarantee that this permanent magnet thing still doing its thing, even though it's going that fast. Still doing its thing. It doesn't mean, it doesn't like skip over it just because it's going fast. Oh, now it's pushing on a gyro. You can hear it. It's trying to flip. Still happening. So like I said that it would work at any frequency, and it will. Yeah, I love that sound, man. It's those gyros trying to flip. All right, so I got one thing that I can try to make that happen faster, and that's to flip this over. So now it's all repelling. It's all repulsion. Let's try flipping. Oh man, that would be sweet if they were flipping. They are. Holy cow. Awesome, man. It's working. But, you know, at a lower frequency, everything's going to pound harder. It's going to pound way harder. As you can see, this is a perfect example. When it slows down, it's going to start flipping them. Very cool. So those of you who stuck around to see that and enjoyed it, thank you. I really appreciate it. Anybody else want to see this? I mean, it's not really tremendously significant, but the way I have this set up, these gyros will gyro. So let's give it a spin. And as it slows down, as the frequency gets shorter, or lower, it'll pound harder. That's so cool. Well, thank you very much, ladies and gentlemen. Peace out. Have a wonderful day. Bye now.